Okay, so I wanted to talk a little bit about subnetting. We created a packet tracer with some basic instructions, and what we wanted to do is look at the networks on this packet tracer and using VLSM, or variable length subnet masking, assign network ranges for each of these subnets. We have LAN 1 with 30 hosts, LAN 2 with 14 hosts, LAN 3 with 28 hosts, and LAN 4 is just 6 hosts. So the first thing you want to do when you're facing this is actually list all your networks from largest to smallest. And I actually like to use a sheet of paper. You can use a whiteboard or whatever is most convenient for you. I'm going to use the whiteboard here in the classroom. Okay, so the largest network is LAN 1. And that's got 30 hosts. Second largest one is LAN 3. It has 28 hosts. And LAN 2 has 14 hosts. And finally, LAN 4 is the smallest one with just 6 hosts. So remember that when we're doing subnetting, we have to write down the subnet masks for each of our networks using binary. But what we're going to do is we're going to put up the binary placeholder values up here in the top right so we can have them. And I'm just going to go up to 32. We're not going to need larger than 32 in this. So to pick a network, excuse me, we need to pick a network that is large enough to accommodate 30 hosts in the first network, but just large enough. And on the on our placeholder values, we have 1, 2, 4, 8, 16, and 32. So 32 is the number of hosts that we would need to accommodate 30 hosts in LAN 1. And the rest of these will be zeros. And remember, if we're doing slash notation, remember there's 24 ones to the left of this. So this is 25, 26, 27. So this is a slash 27. If we're looking for the subnet mask, by the way, put the remaining placeholder values here. Subnet mask for a slash 27 is these three numbers added together. And I think that you'll see that comes to 224. So this subnet mask is 255.255.255.224. I'm just going to write the last octet down to save some space. So let's look at the second network. It's LAN 3. It has 28 hosts. And again, it's actually the same size, because if we went to the next size smaller, is 16, that's not enough hosts to accommodate 28 host networks. So we have to go up to a 32, to a slash 27, the 32, the magic number of 32, above the 27th bit. So this will be, so LAN 3 will be a slash 27, and that will be the same subnet mask, .224. Now to accommodate 14 hosts in LAN 2, we can actually go smaller. We can go put a 1 here above below the 16, That gives us 4 ones in the last octet, which is a /28. The subnet mask, again, you add up all these numbers, 128 plus 64 plus 32 plus 16, and that comes to .240. So it's 255.255.255.240. And the smallest network is 6 hosts and 8. An 8-host network, which is a /29, is just big enough to accommodate that. And if you add in the 8 to the 16, 32, 64, and 128, you get 248. So that's your subnet mask. So we've got our networks. Now we need to figure out the host address, the broadcast address, and the range for each of these networks. And this is going back up to our magic number. Give myself a little more room. So we'll write our subnet mask, our /27, that's 27 ones. So that's 8 ones in the first octet, 8 ones in the second octet, 8 in the third octet, and then that's 24. So 25, 26, 27. Should give myself even more room. We put our placeholder values above this. 1, 2, 4, 8, 16, and 32. $32 is our magic number there. It's the value above the last one. So we know this network has 32 IP addresses. The network starts at .0, and our range is 172.30.1.0 is our network that we're starting off with, which that's in the packet tracer. Here. I'm going to write that above. So the network address is .0, 172.30.1.0. The next network starts 32 places after that. We figured that out with the magic number here. Now this network is the same size, LAN 3, so that's also 32. So we're going to count up 32 from here. So the next network will start at .64. Now I'm going to erase this and give myself a little more room. I'm moving the screen around and everything. This is a /28. We've got 24 ones to the left of the last octet. The last octet is a /28. So this is 25, 26, 27, 28. The rest are zeros, subnet mask. Magic number above this is 16. You can also get this answer by taking the zeros, which are your host bits. You take a 2 to the fourth power, because there's 4 zeros. That gives you 16. Either way you do it, doesn't matter. The 16 is the number you want. So the next network is going to start 16 above .64, .80. Now we're going to take a look at where the next network ends. Even though we don't have a 5th network on here, we still want to know where the next one begins, because it'll make it easier to figure out where this network ends. And This is a /29. So we got 28 here. That's 29. Our magic number on the next network is 8. So the next network will start at .88 if we had a next network. The reason I wrote this down is because it's easier to figure out the broadcast if you know what the next network starts at. And broadcast is the next thing we need to figure out. We're going to put the broadcast over here. This is the network. This is the broadcast. So the broadcast is going to be the last IP address in the range. We know that this one starts at 0, and the next network starts at 32, which means the last IP address in this range is .31, and that's the broadcast. Same thing. Look at the next one up. The third network, or LAN 2, which is the third largest network, starts at 64, which means that .63 is the last IP address in the previous network's range, and that's the broadcast. Look at the third network. Look at where the fourth network starts. It starts at 80, which means that the one before it is .79. And the reason I defined where the fifth imaginary network would start is so that I could figure out that the broadcast for the last network is .87. And our usable range is always one above the network address. Use a different color. One above the network address, which in this case is 1, and one below the broadcast. This is our usable range of host IP addresses, which is what we can assign to router interfaces and computers and laptops. And what we assign the switch virtual interface to. Notice this network down here. It called for a 6 host. It only had 8 total. Take out the network and the broadcast, and you're left with exactly 6. 81 through 86. All right, so let's take a look at this packet tracer. First thing it asked us to do was, using VLSM, assign subnets to each LAN from the IP pool 172.30.1.0/24. It's a full class C. That's 256. It's from 0 to 255. This is done. That's what making this list did. We have our 4 networks. We have a subnet masks. We have our network IDs, our broadcast IDs, and our usable range all defined for us. So let's look at step 2. Configure the default gateway interface for each LAN with the first usable host IP. Well, the first usable host IP, let me go back to our whiteboard here. First usable, right there. LAN 1 is 172.30.1.1. LAN 2 will be .1.33, etc. So we have that. All we need to do is assign it to the default, to the interfaces for the routers. We also need, in order to set up the interface for the routers, we need the subnet mask, which is why I took the time to calculate that out, even though I had the /27, the slash notation, which is the same thing. But when we set up the router interfaces, it wants to see the subnet mask. So we need to know what the subnet mask is. But we have that information. So let's go ahead and set up those interfaces. So R1 Yep, this is G00, I believe. Yeah, so I've got them set up semi-logically. All right, so let's open up R1. Go into privileged exec mode, then configuration mode, and we're going to go into interface mode. The interface, this is gigabit 00. That's the interface that's connected to LAN 1. Remember, we're not going in order. We're making sure that we use the LANs, the proper IP addresses for the LANs. These don't go in order. You know, we chose largest to smallest, not first, second, third, fourth. You know, the LAN 3 is the second largest. LAN 2 is the third largest. But LAN 1 is the largest. So we'll start with LAN 1. That's on interface gigabit 00. And just assign the first usable IP address, which is 172.30.1.1. Subnet mask is 255.255.255.224. And let's enable it by typing no shutdown. And in time, it'll turn all green, just like that. Okay, so let's go to interface gigabit 01. That is connected to LAN 2. LAN 2 is the /28. It starts, its network ID is 172.30.1.64. Its first usable is .65. Subnet mask on that network is .240. And again, we will enable the interface. And let's go over to router 2 while that's kind of figuring itself out. LAN 3, that's actually the second largest. Its network address is .32. Its first usable range is .33. Yep. And it would help if I went into interface mode. This is on gigabit 00. No, it's not labeled, but trust me, that's where it is. All right, and now let's go to interface gigabit 01, which is what LAN 4 is attached to, and that's our small network. We'll make sure it went over to, we'll make sure I'm right on the right interface. Network ID on that is .80. First usable address is .81. Subnet mask is .248. Okay. Fast forward a little bit, everything is green except for the point-to-point, which we haven't addressed yet. Step 2 is done. So, configure a switch virtual interface. This is covered in module 2.7. This is what allows a administrator to access a switch remotely. And it says to configure a switch virtual interface on VLAN 1 for each switch with the last host IP address from each subnet. And I recorded that as well on that on the whiteboard here. You know, the switch for LAN 1, like I know, the IP address for that is going to be .30. If you need review on how to set up a switch virtual interface, it is in section 2.7. Let's go to interface VLAN 1. Set and assign the IP addresses 172.30.1.30 subnet mask 2.224. And again, enable it. In a real world situation, we'd probably be setting up SSH in this case, but the instructions don't say to do that. It just says to create the SVI. So that's what we're going to do. Now, LAN 2. LAN 2, last usable IP address is .78. And it's .240 for the subnet mask. All right, I'm not going to bother setting up LAN 3 and 4. I think you understand, you get how to do that. So let's go on and to the next step. Assign IP addresses for the host IP pool for each subnet to end device. So the end devices. And this is where you need to know your range. This is in LAN 1. Range is 1 to 30. Remember, we used 1 for the interface and we used 30 for the SVI. So the next usable one is .2. Subnet mask is still .224. And we're going to find the gateway. And that's .1. That's .30.1.1. And we'll do the same for PC1, which is on LAN 2. LAN 2, its range is 65 to 78. But we've already used 65 and 78, so 66 will be the next one. Subnet mask is still .240. Default gateway on that is .65. And let's just do a quick ping here from PC0 to PC1. Yep, and that was successful. That's good. Okay, I'm not going to touch these over here. I think you guys understand how to do that well enough. I don't think you need to see me do it 4 times. Next step, configure the WAN network, and that's the serial connection that goes between the 2 routers with the appropriate IP number from the network specified. 10.1.1.8/30. Let's go back to the whiteboard. I'll screenshot that later, but I'm going to erase that and I'll show you how to figure out that network. Maybe I'll just use the bottom part of the screen. All right, yeah, let's just use the bottom part of the screen. So 10.1.1.8 is the network, and it tells us that that is the network ID. So we know that. We just need to know what the range is. So .30, let's write our binary subnet mask out here. There's 8 ones in the first octet, 8 ones in the second octet, 8 ones in the third octet, and that gives us 24, 25, 26, 27, 28, 29, 30. And then the last 2 are zeros. put our placeholders above here. We see that the magic number is 4. We could also have done this 2 to the second power, which is 4. Either way. So we know that the next network up is 4 above this, so it's 12, which means our broadcast is .11 and our range is 9 and 10. By the way, might as well do the subnet mask. We know that all ones here will be 255. Well, let's subtract out the 1 and the 2 above the zeros, which is -3. That gives us 252. If you want to add up 128 plus 64 plus 32 plus 16 plus 8 plus 4, you would come up with the same answer. So that's our subnet mask is 255.255.252. So let's set up those on our packet tracer, the WAN link with those IP numbers of .9 and .10 with the .52 for the subnet mask. Okay, so it's serial 010. That's serial 010. Okay, I wasn't sure what the interface was. So interface serial 010. IP address, and we determined it was 10.1.1.9. And a subnet mask of 255.255.255.252. Shut down. Because the other end is shut down as well. And this will be .10 will be the IP address. Same subnet. And it turned green. Okay, like I said, the only thing we're missing from completion on this is setting up the SBIs on the switches and the doing the host, assigning the host to these. But I think you understand how to do that. If you have any questions, you know how to reach me. And have a great day.